Hello everyone, this is Manjushree. I teach physics concepts. In my previous videos, I have explained about force and pressure concepts, how liquid and gaseous molecules exert pressure. And in this video, I'll be explaining about atmospheric pressure. And this is the last video of force and pressure chapter of class 8 NCERT syllabus. What is this atmospheric pressure? To understand atmospheric pressure, first let me explain what is atmosphere. What is atmosphere? You might have heard about this word atmosphere in your day-to-day life, but this atmosphere consists of different layers that I have displayed in this slide, where I have mentioned the bottommost layer, that is the layer just above the Earth's surface, is called troposphere. Then comes stratosphere, mesosphere, thermosphere, and exosphere. As I explained in liquids, the pressure in atmosphere also varies according to the layers of the atmosphere and the density, how it that is the density in the different layers of the atmosphere. And in this slide, I'll just explain where the density will be more in this atmospheric layers. In the topmost layer, the density will be less when compared to the bottommost layer. Why? Because the bottommost layer of the atmosphere will be experiencing the force exerted by all the layers above it. That is, atmosphere means there will be presence of air molecules, and that air molecules will be having weight, and whenever they move randomly, that movement of that air molecules which is having weight will exert some force, and that force per unit area, force means any action which is done by an object, and the movement of that air molecules will create force. Force per unit area will give us pressure, and the force per unit area which is created by the air molecules will give us atmospheric pressure. Atmospheric pressure means it is the pressure created by the atmosphere. What is this atmosphere? Atmosphere means the air molecules which envelop the planet which we live. That is, an atmosphere is a layer of gas or layers of gases that envelop a planet and is held in place by gravity of planetary body. And this atmospheric pressure vary in different layers. As I told you earlier, the atmospheric pressure will be more in the bottommost layer. Why? Because this layer will be heavily dense, highly dense. Why? Because this layer will be experiencing the pressure exerted by all the layers above it, and also the air molecules which are present above this layer will be exerting pressure, that is the weight of all these air molecules will be held by this bottommost layer of the atmosphere. Therefore here the density will be more. If the density is more, then pressure will be more. That I explained in detail about atmospheric pressure point wise in this slide, that is air as weight. So the atmosphere consisting of tremendous amount of air as enormous weight. The weight of atmosphere exerts pressure on surface of earth, and on surface of earth all the objects on earth including us, that is human being also, atmospheric pressure will be exerted on human beings also, but we won't be able to experience atmospheric pressure. Why? Because equal and opposite pressure will be created by every human being on earth. Therefore it will be balanced, and atmospheric pressure won't be experienced by any of us. And I told you atmospheric pressure will be maximum in the that is the surface which is next to the earth surface, that is troposphere I told. Why? Is because there the density will be more. So by considering this concept, try to answer this question, that is, you and your friend have gone to some place for vacation wherein you are in some beach, your friend is in some hill station, and when we compare the pressure experience, atmospheric pressure experienced by you and your friend, experienced by you means you won't be able to experience atmospheric pressure, but the atmospheric pressure uh, in the place in which you are present and the atmospheric pressure in the place in which your friend is present, where the atmospheric pressure will be more. I told atmospheric pressure will be more in the bottommost layer of the atmosphere. So you are in sea level means atmospheric pressure will be more. Why? Because it is in the lower surface of the atmosphere where the density is more. You are in beach means you will be able to see at more atmospheric pressure when compared to hill station. Why? Because in hill station we will be in upper layers of atmosphere where the density is less. If density is less, then pressure exerted by the air molecules will be less, whereas in sea level what happens, density will be more, therefore the pressure exerted by the molecules where the density is more will be more. Therefore I have concluded with the on the earth's surface the atmospheric pressure is maximum at sea level and the air column above us is tallest at the sea level. What is this air column? To explain that, what I'll do is I'll consider earth's surface, and on earth's surface I'll consider unit area. Unit means which is equal to 1, and above this unit area, whatever the atmospheric layers present, that atmospheric layers will be exerting pressure, and the pressure exerted by this atmospheric layers on this unit area is considered as air column above. That is what I have explained, that is air column above us is tallest at the sea level. That is, if we consider this air column in the sea level, then that will be the tallest air column, therefore there the density will be more and also the height will be more, therefore the pressure created in that region will be more, and the atmospheric pressure created on surface of earth is equal to 101.3 kilopascal, or else it is also said to be 1.01 3 into 10 power 5 pascal, which is, and that pressure will be equivalent to weight of 10 elephants pressing on each square meter. That is, if we place 10 elephants on this square meter at a time, and the weight experienced by this region will be equal to 1 atmospheric pressure. That is, the atmosphere which is exerting pressure on this region will be equal to the weight of 10 elephants standing at a time on this region. And what are the other examples of atmospheric pressure which we observe in our day-to-day life is, you might have observed syrup bottles which is connected to a filler like this. And here, what is the physics or atmospheric pressure concept which we can observe is, whenever I want to fill this filler with a syrup or any of the liquid which is there inside this bottle, what I'll do is I'll press this filler. When I press the filler, what happens? The air molecules which is present nearby to it will be that is will be disturbed, and when I release it, what happens, the air molecules which is present in nearby to it will be entering to the filler, but the pressure created inside this filler by the air molecules will be less than the pressure created by the air molecules which is surrounding it. Therefore, when I try to fill the syrup or the liquid which is present inside this bottle will go in easily inside this filler. Why? Because there will be difference in atmospheric pressure as well as the pressure created inside the uh, filler. The pressure created inside the filler will be less. The pressure created by the atmospheric pressure around it will be more. Therefore there will be difference in pressure, and the liquid will enter into that filler easily due to this difference in pressure. And the same physics which we can observe in the straws which we use while drinking any of the liquids. So if we want to drink tender coconut or any fruit juice, what we'll do, we'll use straw. When we use straw, what we'll do, first we suck the straw to get the liquid, and when we do that, air molecules nearer to it will enter the straw, and those air molecules which enters the straw will create pressure inside the straw, and also the air molecules which is surrounding it will be creating atmospheric pressure in around it. But the atmospheric pressure will be more when compared to the pressure inside the straw by the air molecules which are present there. Therefore this difference in pressure will help us to, that is, help the liquids to get inside the straw and help us to drink the liquids which we want to have using the straw easily. And not only this, in our day-to-day life we can observe atmospheric pressure in n number of examples. One such example is, you might have heard about the word rubber sucker, where we place the rubber sucker on any of the wall or any of the object wherein we want to display any of the object. What happens there is, when we place the rubber sucker, the air molecules which is present in that region will move out, and there will be very little quantity of air molecules inside that rubber sucker, and that will be creating pressure, and also the air molecules around it also creating pressure. Whereas this will be attached to the wall or any of the object in which we place, and if we want to remove it, we need to exert pressure on it, such that it should, the pressure which we are applying, the force which we are applying, that force per unit area should be equal to the pressure which the rubber sucker is experienced by the atmosphere. And these are the examples of atmospheric pressure. And in this video I have explained about what is atmosphere, what is atmospheric pressure, and what are the atmospheric pressure which we see in our day-to-day life. In my further videos, I'll be explaining many concepts of physics of class 8th, 9th and 10th. Thank you.